Hi, and welcome to this flipped instructional session. This instructional session is for Middle School Earth Science, Semester A, and today we are going to be reviewing for the Unit 2 test. Today's instructional session is really important because it will help you prepare for the test, and then you can attend the flip follow-up and play some review games. I'm Mrs. Fessel, and let's get started. Again, this is the Unit 2, Semester A, Earth Science review. So we're going to start off talking about what are the traits of a mineral. So all minerals must be a solid, can't be a liquid or a gas, must be inorganic. So inorganic means not living, because the prefix in means not, inorganic means living. So it must be not living, which makes sense because rocks aren't alive. It must be naturally occurring, forms by itself in nature, and then two other things it must have are a definite crystalline structure. What that means is that's what this picture over here is showing, that the mineral's atoms arrange themselves in a certain way, causing it to have a crystal structure. Then it also has a definite chemical composition. Each element's chemical composition is different, but all minerals of one type are made of the same element. For example, every single diamond, which is a mineral, is made of pure carbon. So each mineral has its own chemical composition that doesn't change from diamond to diamond, for example. Then we have some tests that are used to identify minerals. The first of those tests are for the physical properties, or the properties that can be observed without changing the makeup of the mineral. So some of these physical properties include color, which is the most easily observed, because you can see it by looking at it, but least reliable property. That's because, for example, quartz can come in many, many different colors, so it's not very reliable. Rocks could also be dirty. Two minerals could be the same color, so it is the least reliable property. A more reliable property shown here is streak. Streak is when the mineral is rubbed against a ceramic plate and you look at the color of the dust that's left behind. So the streak is important because even if a mineral is a different color, the streak will not change. So it is much more reliable than color. Next, we have hardness, or the resistance of a mineral to be scratched. If a mineral has a low number, for example, down here, these ones are soft. It leaves marks or gets grooved, and it's scratched easily. Up here, these ones with higher numbers can scratch other things and have a greater hardness. So some things that are used are a fingernail, which has a hardness of about 2.5, a penny, a nail, a glass plate, or the streak plate can all be used to help identify the hardness of a mineral. The last three physical properties we're going to talk about are cleavage, fracture, and luster. So cleavage is when a mineral separates along flat surfaces. For example, some minerals break into cubes, other minerals such as mica break into flat sheets. This mineral down here in the middle, you can see that it's breaking into cubes, and that shows that this mineral has cleavage. On the other hand, if a mineral has fracture, such as this one here to the left, it will not break along flat surfaces. So it'll break in directions other than along crystal faces. So if you can see here, you can see it's breaking in circles and uneven edges. So that would be fracture. It does not break along flat lines. Then finally we have luster, how the mineral reflects light, or for example, how shiny it looks. So two words that geologists often use are metallic or non-metallic. For example, this sample here would be considered metallic because it reflects the light and looks like a metal. Then we have a few chemical properties. These aren't as easy to observe. For example, the flame test. Depending, again, back to that chemical composition, depending on the chemical composition of a mineral, it will burn a different color because different elements burn different colors. Solubility, or how a mineral dissolves in water, and then an acid test. For example, this sample of rock bubbles when a strong acid, such as hydrochloric acid, is placed on it. So those would be the chemical properties of a mineral. Some minerals are referred to as ores. which is a mineral that is valued because it contains large amounts of a useful element. So that's all an ore is a mineral that is useful. For example, ore bauxite, which is pictured right here, it contains aluminum. As we know, lots of things are made of aluminum, such as aluminum cans, and that makes it useful. So anything that is an ore is simply a useful mineral. Then we also have silicates. For example, quartz is an example of a silicate. Silicates are the most abundant minerals in the Earth's crust and mantle. That's because the element silicon easily binds with other elements such as oxygen, making silicates the most abundant minerals in the Earth's crust and mantle. Now we're going to go into rocks. So of the three major types of rocks, we're going to talk about metamorphic, sedimentary, and igneous. So metamorphic rock, the two key words for metamorphic rock are heat and pressure. Metamorphic rocks form deep within the Earth when the pressure from the layers above it and heat from deep within the Earth make these rocks right here in the middle transform into metamorphic rock. So it's important to note that metamorphic rocks don't melt. If it had melted from the heat, that would become an igneous rock. But the heat and the pressure are just enough to change it to a different type of rock. The prefix meta and morph mean change. So a metamorphic rock is morphing or changing into another type of rock. Next we have igneous rock, which, as I mentioned a moment ago, igneous rock is rock that forms from cooled lava or magma. So this is once a rock melts, it turns into lava or magma. Once that lava or magma cools again, it forms a new type of rock, igneous. So there's two types of igneous rock. Up here, this is intrusive igneous rock. The prefix in tells us that this type of rock forms deep within the Earth, in the Earth. So because it forms from magma that cools very slowly, there's time for large crystals to form, as you can see in this picture. They are large crystals and they are coarse-grained or rough because it cools slowly and these crystals have time to form. On the other hand, down here we have extrusive igneous rock. X, the prefix, tells you that the lava has exited the Earth and it cools quickly because when that lava hits the cool air, it causes the rock to cool quickly. So extrusive igneous rock forms when lava cools quickly on the Earth's surface that lava has exited. So this type of rock has small crystals and is fine-grained because of how quickly it cools. The crystals don't have time to form. Finally, we have sedimentary rock. So for sedimentary rock, we need sediment. That's what the base of the word sedimentary. So first what has to happen is another type of rock, either igneous, metamorphic, or a different sedimentary rock, has to undergo weathering and erosion to break it down into very small pieces of sand, clay, and dirt. Then that sediment gets compacted and cemented together to form layers. So for example, this picture is showing sedimentary rock because you can see all these different layers of sediment that have been deposited, compacted, and cemented together. That's the end of today's flipped recording. Again, I hope you can join me for the flipped follow-up when we'll play some review games and help you study for your Unit 2 test. Have a great day. Bye.